Good morning. Happy Friday. You all have made it through our first official week of distance learning, and I'm so proud of all of you. So these lessons will always be up on my YouTube channel if you want to refer back to them. For those of you who have worked through lessons 17 and 18, I am just so proud of you. For those of you who've watched the YouTube videos, keep taking notes, keep learning more about our fractions. You're going to notice that the last lesson that we did was lesson 18. I actually skipped lesson 19 because it was just a review. It was an optional lesson. And so we are actually going to focus on lesson 20 today. You're going to see that it says our objective is to recognize and show that equivalent fractions have the same size, though not necessarily the same shape. Okay, so I just want to really quickly before we get started, I do want to highlight this word equivalent. Equivalent is very similar to saying the word equal, all right? So we're trying to find fractions that are the same, right? That are maybe equal the same, even though they're not maybe the same size. So this might be really confusing right now, but I'm confident you guys can do it. Also, I noticed that some of you have already started working on our packet that I gave you. There was a worksheet about equivalent fractions on a number line. That was something we had not learned yet, and a lot of you guys have already tackled that assignment. I'm really proud of you guys for doing that. Hopefully this will start making a little bit more sense, but I know that as we work through equivalent fractions, you guys will get it. So let's get started. So our fluency practice today is going to be skip counting by sevens. Now, if you had seen on Class Dojo, I had posted an activity for you guys to do where you could record a video to me, which is if you are connected to Class Dojo as a student, you can record videos or respond to my assignments. And so one of the assignments I had put was a challenge to recite your sevens times tables to me without looking at a paper. So you need to really practice and memorize. I find that sevens tend to be one of our trickier numbers to memorize. I had one student so far submit his responses. So shout out to Sean. He did a really good job. He even actually sent me 2 videos because he realized the first one he had made a mistake, which is okay. And so I'm really proud of him and his hard work. I want to encourage those of you who are connected to Class Dojo to send me a video of you reciting your sevens, especially after practicing. So let's skip count by sevens. So we have 7, 14, 21, 28, 35, 42, 49, 56, 63, 70. I do want to encourage you, for those of you who have a notebook and a pencil or a pen or marker, write that down, really practice it this weekend. Okay? Now, if I circle 35, what multiplication problem do you think we could say that would equal 35? If you said 5 times 7, which equals 35, you are correct. Notice we are counting by sevens, and we can actually look at what number in the sequence is 35. We could say, okay, it's not 1, we go 1, 2, 3, 4, 5. It's the 5th number in the sequence, so 7 times 5 is 35. Okay, let's skip count up by sevens again to find our answer for 3 times 7. Okay, we have 7, 14, 21. So your answer for 3 times 7 is going to be 21. So we can see that. We're going to skip count again, 7, 14, 21, and that was the answer. Okay. We're going to do another one. Let's skip count by sevens. Let's skip count up by sevens again to find our answer for 9 times 7. 7, 14, 21, 28, 35, 42, 49, 56, 63. I'm going to want to show you guys that this is a really good strategy for us to know our sevens facts. You can skip count. So we have 7, which is 1. It's 1. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6, 42. 7 times 7, 49. 7 times 8, 56. And then 7 times 9 is 63. So this is our answer. Okay? Now, it does say that we would have practiced on our pattern sheet. This, once again, would have been in your Fluency workbooks. But like I said before, I would like for you to go ahead and recite your sevens facts to me on a video. So if your parents are not connected to Class Dojo and they just want to send me a text message of a video of you reciting your facts, that is okay as well. Okay, now our application problem today is going to be pretty tricky. So try your best to follow along as best as you can. We're going to take it pretty slow. And I would like for you all to go ahead and have your scrap paper ready. And we're going to use our rice strategy. Once again, we write rice down the side to help us know which steps we are on. Our first step is always to restate the question. And we haven't even read it yet, but just think about ways you could restate the question. I'm going to read the problem now, and it says, Max ate 2/3 of his pizza for lunch. He wanted to eat a small snack in the afternoon. So he cut the leftover pizza in half and ate 1 slice. How much of the pizza was left? Draw a picture to help you think about the pizza. Now, it says how much of the pizza was left? That is our question. So one of the ways you could restate that question is blank of the pizza was left over or left. Okay? Now we are going to illustrate our picture, and I am going to just show you really quickly a few things. On the next slide, you will see that part of my drawing will be a little bit more confusing. So I'm going to try to break it down just slightly with looking at our illustration here on the side. So you can see I have a little bit of blank space on the bottom. That's where I'm going to start my drawing. So it says Max ate 2/3 of his pizza. We know that most pizzas are in a circle. Okay. And we're going to cut it apart into thirds. And one of the ways I taught you all to cut things into thirds, especially with a circle, is to kind of think of it like an upside down Y or a peace sign. So I'm going to start by cutting it down in a little bit. I'm going to stop halfway. And then I'm going to make 2 diagonal lines. And there are my thirds. All right. So we know that there's 1/3, 2/3, 3/3. That's the whole pizza. Now, excuse me, I just sneezed. Is anybody else struggling with allergies? Because I am. I really struggle with allergies right now. Okay, so he ate 2/3 of his pizza for lunch. So I'm going to color those sections in with red. So I'm just going to show you that I'm coloring it in. So here is 1/3. Here is 2/3. There's 2 of the thirds are colored in. Okay. So he ate 2/3 for lunch. What is left over? What is left over? Okay, what is left over is 1/3. However, it says that he cut the leftover pizza in half and ate one slice. So I'm going to use a different color, and I recommend if you have been using a pencil, this is the time when you could bring out your colors. Using a different color helps us see exactly what I'm talking about. So I'm going to use blue. Maybe I'll use a brighter color. I'm going to use, light blue. Okay, so we're going to see that he cut this pizza slice in half. Okay, I'm going to shade this in. Okay, and we're going to label that as S for a snack. Okay, small snack. Now, this is a little bit harder to see. Like, what fraction would this possibly be? Now, we can visualize maybe by cutting each of these slices into half and seeing if you guys can figure out what fraction is it. If we were to cut all of these pieces into half, the big thirds into half, how many equal pieces do we now have? We have 1, 2, 3, 4, 5, 6. So how many equal pieces would we have had if we had cut the thirds all into half? Then it would be 6. We would have been talking about 6. So what was the measurement of one of those slices, one of those smaller slices? A snack, so I'm going to label it as an S. His snack was 1/6. Okay, so then how much of the pizza was left over? How much of the pizza was left over? So this is his leftover. We can label it as an L. So how much of it was left over? And I decided I'm not going to label it as an L. And the reason why, I just realized that it would be confusing because some of us might have labeled the other ones as lunch. Okay, so this is going to be his leftover. So we're going to maybe label it as an O. Okay, leftovers. His leftovers, remember, we decided to show this as splitting it up, visualizing splitting all the thirds into half, and that would have given us now 6. Okay, so imagine, eating 1/3 for lunch. I'm going to put that over here, lunch. If he ate 2/3, right? He ate 2/3. That's the same as saying he ate 1, 2, 3, 4 6s. See that? See how I just split everything up into 6s now? Okay. So 2/3 is the same as saying 4 6s. So what does he have as a leftover? He has 1/6 of the pizza left over. Okay. We restated our question, which is how much of the pizza was left, and we restated it as saying blank of the pizza was left. I just showed you this illustration by showing you that he ate the red. Remember, he ate all of the red, which was 2/3. Then he cut the last third in half, and to help us understand what that would look like, we cut all of the other thirds in half and found out that would have been 6 equal slices, hypothetically. And so his snack was 1/6. So what was left over? We had another 6. Okay, let me show you my other picture. So you can see I labeled this as well. I showed you that 2/3 he ate for lunch. Okay, 1/6 of the pizza was left over because I cut that last third in half. And I needed to cut the other thirds in half in order to see that would have been 6 equal slices. Okay, I want you to explain how you might have figured this out. This one is a trickier problem. We will revisit something like this again. So I'm going to give you a few minutes to just explain your thinking. If you do not understand at all, please go ahead and send me a message either through Class Dojo or a text message and send me that you did not understand the application problem. This is setting a foundation for how we can look at equivalent fractions. Okay, so here's where we're going to talk about the meat and potatoes of our lesson. This says that the whole is all of the cubes. So how many cubes do we have? We have 1, 2, 3, 4 cubes. So our whole would be what? Our whole, so one whole would be 4 out of 4. Now, if you were at school one day a few weeks ago, we did an activity talking about Skittles. And this is one of those things that kind of will remind us of using the Skittles to help us figure out our fractions. So when we look at our fractions today, we're going to always be looking at this figure for this part of our lesson. So we'll be talking about fourths. All right, and it's asking you to whisper, or you can write it down on your paper, to your partner, the fraction of cubes that are blue. So obviously you don't have a partner unless you want to talk to your parents or a sibling. But what fraction of the cubes are blue? Now you wouldn't want to just say 1 is blue. You would want to say 1 what? So I'm going to label it as B. And the blue, the fraction that are blue is 1 over 4, or 1/4. So 1 out of the 4 is blue. Now, how many of them would be red? There are 3 out of the 4 that are red. Now, let's look at this figure. It says the whole is all of the cubes, so our whole has not changed. Our whole means that we still have 4 out of 4. Now remember, our goal is to look at how these fractions might still be the same even if the figure or the shape changes. So it says to whisper again to what fractions of the cubes are blue. What is our fraction? How many out of the 4 are blue? If you wrote down 1/4, that is correct. Once again, we can look at 1 out of the 4 is blue. Now, how many are red? There are 1, 2, 3. 3 out of the 4 are blue, or I'm sorry, are red. Notice how even though this figure is long ways and this one is in a square, the fractions have not changed. They are the same. So then look at this other picture. We're going to do a little activity. It says to color the white 1/3 red. Okay, so you're going to see that this one, you can do this with paper if you would like to. I want to show you guys what it's really trying to have you guys do, okay? They're asking you to make it into a different shape, okay? 2 to 4 smaller shapes. We're going to cut all this out. So what it's going to look like is something like this. You would have cut out, making them into smaller squares, okay? I don't need you guys to be doing this unless you really want to. I would say you can pause the video, you can read the directions, you could try it your best. I don't really need you guys to go ahead and do that activity because it is harder to do unless I was doing it with you guys. So if we were in class, we would have used materials to try this out. But let's go ahead and look at our exit ticket. This is what you guys are going to be looking at when you do a quick little activity in Microsoft Teams. It says to label what fraction of the figure is shaded. Then circle the fractions that are equal. So which means that they need to be the same. Which fractions are showing you that they're the same? So we're going to do number 1 together. And remember, you don't want to just say that there are 3 that are shaded in. You want to figure out what is the total amount and then how many are shaded, just like what we were doing in the very beginning of our fractions. Okay? So we know that there are 1, 2, 3, 4, 5 total cubes for this one, and then there are 1, 2, 3 that are shaded. So our fraction here is 3/5. There are 3 out of 5 total shaded. Excuse me. Okay, so let's look at this next figure right here. We have 1, 2, 3, 4, 5 cubes again, and there are 3/5 shaded. Now, what fraction here are they shaded? And it says 1, 2, 3, 4, 5. They're still talking about fifths. And there are only 2 out of 5 shaded. Now, this last one, we have 1, 2, 3, 4, 5. And there are 3/5 shaded. Now you can see that all of these had 5 cubes. All of them were in fifths, but only 3 of them have the same answer, where they are all equal. Even though they look a little different, they're equal. So I'm going to circle those figures in red, because it did tell us to circle the fractions that are equal. So we know that this one, is the same as this one, and the same as this one. They're all 3/5. Now, number 2 asks us to label the shaded fraction, and then you need to draw 2 different representations of the same fractional amount. What that means is you would need to draw squares and show me that you can make it into different figures, kind of like these ones, right? Kind of like how they made the figures all sorts of weird ways. Different representations of the same amount. So the first thing you need to do is to label the shaded fraction. So let's figure out how many there are total and then how many are shaded. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we know we're talking about 11s. And we need to figure out how many are shaded. There are 1, 2, 3, 4, 5. Okay, 5 out of 11 are shaded. So what you would need to do is you would need to figure out a way to make a figure, make there be 11 equal boxes, shade in 5 of them, and that will show me a different representation. You can do that on your notebook. And that is what you will be doing for work this weekend. So if you have a chance to go on to Microsoft Teams, or if you need me to share this with you separately, I can, but I will be attaching just the lesson 20, actually, the problem set. So you're going to be able to see the problem set is going to look just like this. And you are going to go ahead and have a chance to do your problem set all on your own. If you see, this is the first part of the problem set, and you are just going to be doing exactly what we did in our video right here, where you label the fraction of each shape shaded, then circle the fractions that are equal. I want to go back and just remind you that our goal of our lesson today I have to go all the way back. Sorry. The goal of our lesson today was just to recognize and show that equivalent fractions can have the same size, though not necessarily the same shape. If you guys remember, those might have been different shapes. They might have been different shapes, all right? But they still were using they were still the same fraction. So to just remind you, I wanted to show you guys really quickly, these are different shapes. They're not all the same shape, but some of them have the same fraction. All right, guys, I hope you have a really good weekend, that you guys enjoy time with your family, enjoy watching some movies. I just recently watched Frozen 2, and I've been listening to some of the soundtrack, and it's been awesome. So I hope that you guys have been enjoying your time, and I hope to talk to you guys soon.